All right, today we're going to unlock one of the most fundamental ideas in all of computer security. We're talking about the keys to the digital kingdom and, more importantly, how we decide who gets to use them.
You've totally been there, right? You go to open a file on a shared drive and bam, access denied. It's super frustrating, and it makes you wonder, who's in charge here? Who's deciding who gets the keys to all this digital stuff? Well, that's exactly what we're going to figure out.
So, to get our heads around this, let's think about access control like it's security for a physical building. It's not just about locking the front door, right? It's about controlling who gets into which rooms and what they're actually allowed to do once they're inside.
Now, if you want the official fancy definition, here it is, from the National Institute of Standards and Technology. But what does all that jargon actually mean? Basically, access control is the digital bouncer standing at the door of your data, checking IDs and deciding who gets in and who stays out.
So how does this digital bouncer make its decisions? Well, it follows a pretty strict three-step process. First up is authentication. This is the "are you who you say you are" step. It's you showing your ID. Next is authorization. Okay, we know who you are, but are you actually on the list to get in here? And last but not least, there's the audit. This is like the security camera, keeping a log of everything you did, just in case we need to review the tapes later. Now, to really understand any of these systems, you just need to know three basic terms. First, there's the subject. That's the person or the program trying to get access. That's you. Then you have the object. That's the thing you want to access, like the file or the room in our building analogy. And finally, the access right. This is the action you want to take. Do you want to read the file, change it, or just delete it entirely?
Okay, let's start at the beginning, with the very first system. The simplest, most straightforward approach is basically like handing out individual physical keys. In the tech world, this is called Discretionary Access Control, or DAC for short.
The key word here is discretion. In a DAC world, if you create a file, you own it. You have complete control, total discretion to give a copy of your key to anyone you want. It's your digital stuff, you make the rules.
So how does a computer keep track of all these individual keys floating around? It uses something called an access matrix. Just think of it like a giant spreadsheet. The rows are the people, the subjects, and the columns are the files, the objects. And the little cells in the middle tell you exactly who can do what to which file. So you can see right here, user A can read and write file 1, but user B, they can only read it. Simple as that.
Now what's cool is you can look at this matrix in two different ways. If you read it down the columns, you get what's called an access control list, or ACL. It's like putting a guest list on the door of every single file. It answers the question, who can get into this? But if you read it across the rows, you get capability tickets. That's like giving each user their own personal key ring that shows every single door they can open. It's the same information, just organized differently. But here's the big problem with DAC. It works great when things are small. But can you imagine trying to manage individual keys for every single employee and every single file in a huge company? A new person joins, and you have to manually create like 50 digital keys for them. It becomes a total nightmare. It's messy, it's inefficient, and honestly, it's a huge security risk. Something had to change.
And that change brings us to the big upgrade. We moved from a world of individual keys to a world of job-based key cards. Welcome to the era of role-based access control, or RBAC.
The idea behind RBAC is just elegant. It's so simple. Instead of handing out hundreds of individual keys, what if we just gave people one key card based on their job? If you're an engineer, you get the engineer key card that opens all the engineering doors. If you're in sales, you get the sales key card for the sales offices.
The logic is this beautiful, clean three-step flow. First, you assign users to a role, like accountant or manager. Second, you give the role permissions, like can view financial reports. And third, the users automatically inherit all the permissions from their assigned role. That's it. It's clean, simple, and it scales incredibly well.
And this was an absolute game changer for big companies. Why? Well, for starters, it's way easier to manage. You're not worrying about thousands of individuals anymore. You're just managing a few dozen roles. It also naturally enforces this super important security idea called the principle of least privilege, which just means people only get access to what they absolutely need to do their job and nothing more. Plus, it just makes sense. It mirrors how real organizations are actually structured.
RBAC is also smart enough to handle seniority. You can have a director role that gets all the same permissions as an engineer role, plus some extra director-level permissions on top. This is called a role hierarchy. and it's a really powerful way to model complex company structures.
But, our digital world keeps getting more and more complex. And sometimes, even knowing someone's job role isn't quite enough. So now we need to look to the future, to this incredibly smart, context-aware system called Attribute-Based Access Control, or ABAC. So RBAC is great, for sure. But what if your job title alone shouldn't determine if you get access? Modern security needs more information. It needs more context. What time of day is it? Where in the world are you logging in from? Is this network even secure? A simple role can't answer any of those questions.
And that is where ABAC just shines. Think of it like a super intelligent security guard. It doesn't just look at your job title, it looks at attributes or details about everything involved. It checks attributes of the subject, what's your clearance level, attributes of the object, how sensitive is this document, and even attributes of the environment. Are you trying to access this after hours or from an unsecured Wi-Fi network?
I know that might sound a little abstract, so let's make it real. Let's use an example we all get, streaming a movie online.
Okay, so here's the policy the streaming service needs to enforce. It's based on two simple attributes. The first is the movie's rating, which is an attribute of the object, the movie itself. And the second is the user's age, which is an attribute of the subject, you.
And here's what that policy looks like as a rule the system can actually understand. It's just simple logic. If the user's age is greater than or equal to 17 and the movie's rating is R, then you're in. Allow access. See? It's just a simple, logical statement that uses these attributes to make a really specific decision on the fly. No static rules required.
Okay, wow, we have covered a lot of ground. So let's take a step back. Let's zoom out and look at the bigger picture of how all these systems fit together.
This table really sums up the whole evolution pretty neatly. You start with DAC, based on an owner's choice, not very flexible, best for small-scale stuff. Then we evolve to RBAC, based on a user's job role, much better, perfect for big companies. And that brings us to today with ABAC, based on all that rich context and attributes, super flexible and built for the complex, dynamic world we live in now. You can really see the trend toward more and more granular control.
And that brings us to our final thought. We've journeyed from individual keys to job-based key cards to these hyper-intelligent, context-aware systems. But as our world gets even more connected, with AI, Internet of Things, and technologies we can't even dream of yet, it leaves you wondering, what new kinds of keys are we going to have to invent to keep our digital kingdom secure?